Hello and welcome back to the final part of the series where we use BLE to communicate between the Pico and the Pi. First we will add a button to send messages between the Pico and the Pi, and then add an LED for LED control. Then we will have the Pi send messages to the Pico with a button to control an LED. Finally we will look at some use cases and limitations of BLE. Let's get started. Alright, let's get started, and we'll start with the wiring diagram. So here we have 2 buttons and 3 LEDs along with 3 resistors. So on the Pico we have this push button, which is connected to ground here, and it's connected to GP0, which is this pin right here. We also have an LED connected here to pin GP1, which is right here. And of course we have a resistor here, and that's connected to the ground here as well. This we will be using to blink when we send commands from the Pi to the Pico. Then for the Pi we have the push button for at GPIO pin 22, and then we have the other leg connected to ground. Then we have 2 LEDs for the Pi. This one is the red LED, which connects to pin 17, which we'll use to indicate when the Pi is connected, just like we've done before. Here's a resistor. This is the green LED, which is connected to GPIO pin 27, and we have the resistor here as well. So my actual wiring will be different, but this will work as well, so just keep this in mind when you're going to wire up your GPIO pins. So let's start with the code. So we'll start with the Pi code first. So here we have the libraries as usual, just like before. This is the button LED. We have our 2 LEDs. This one will blink to indicate connection. Here we'll have pin 27 to turn on. We have our IP address, our MAC address, our UUIDs. And the only thing we need to know here is the receive data task. So if the integer, or in this int response, is equal to 1, or sorry, if the data is 1, the LED will turn on. If the response is 0, the LED will turn off. Else we'll just put no message. And we will sleep at 0.1 seconds since we want to add a small delay. We have our blink task, which allows the LED to blink when there is a connection with the Pico, and it connects for 1,000. It blinks for 1,000 milliseconds, which is 1 second. We have our connect and communicate, and we have our tasks here. Now for Pi button, this is where we're going to send data from the Pi to the Pico, or essentially we're going to ask it to, what we're going to do here is we're going to send data to it by pressing the button and also blink the LED. So we have our usual libraries here. Now we've defined a button at pin 22. Everything else here is still the same, but in send data task we have the current state and a previous state. Previous state is defined as none first, and then we have button is pressed as an integer. That will be the current state, and if they're not the same here, then it will simply send the message as a string, and then it'll send the message. It'll print sending message and show what message is being sent. Then it'll write the message, then it will update the previous state to be equal to the current state, and then we'll have a small delay here. So when I press the button, it'll send a 1. If I release the button, it'll send a 0. We don't need receive data task. We don't need to do that, so I commented it out. So we need to just worry on this. Then we have our Pi button receive, but we're going to be receiving data. The only thing you need to know really here is, aside from the LED and our MAC address and UUIDs, is that I added a 0.1 second delay to match the other delay we're going to use on the Pico. So we are going to read the characteristic UUID, and we're going to read the response, and that's it. Nothing else here. Now let's move on to the Pico. For Pico button, we have our libraries. Everything else is still the same. We have the LED we define. I just kept this here. You can remove this. And of course we have the parameters here. You really don't need the BLE name, but you can keep it if you want. We have our button define, usual functions. The only thing you need to worry about is the send data task. Blink LED task is still the same from last time. So if int, the integer a button is pressed, is equal to 1, it'll send 1. Else, it'll send 0. And of course, it'll encode the message, and it'll write the characteristic, and we have our delay at 0.1 second to match the other function, the Pi button receive code. And that's it. Everything else still stays the same from before. And then we have our Pico receive, where we have our LED equal to 1. Then we have the usual parameters that we've set before. However, we're not going to be sending any data, so just ignore this. What we will be doing is receiving data. So if the integer of data is 1, we will have the LED on. I have the print statement for a sanity check, and if the integer of data is 0, the LED is off, and we print off. This is optional. You can remove the print statements if you want. And we will have the sleep at 0.05 seconds to match the Pi button. But other than that, everything else is still the same, and that's it for the code. So we will be testing out demos. So let's get to it. Alright guys, let's get started with the first demo. So as you can see, I have the terminal ready to go. But first we need to run this piece of code. So I'm going to run this. It should tell me to run. Okay, so I'm going to now, this is Pi button receive, so it should work. So I'm going to get close to the button, and it's already working. And as you can see, it's working. And you can see it's putting 1. And yes, when I press the button, it goes to 1. When I let go of the button, it goes to 0. So I'm holding the button. Now I'm letting go of the button. So this demo does work. So let me exit out of this. And I'm going to exit out of the Pico. So there you go. All right, so let's get to the next demo. All right, guys, so let's do this again with the LED. So I'm going to start this again. And let me go to the shell. So again, I'm using Raspberry Pi Connect. So I'm going to use button LED. So it should connect now. So watch what happens when I turn on the LED. Pay attention to the green LED. So watch my hand when I press the button. You can see that the LED is turning on. And if you look at the terminal, look, I pressed, it says pressed, then released. So let me show you again. Now let me show you with my hand pressing the button. See that? All right, that's it for this part of the demo. All right, here's the next demo. So I'm going to do button receive, as you can see here. So I'm going to get it started. Now I'm going to go with this Pi button. Now I'm going to wait for it to send. So let's press the button. And you can see my hand pressing the button. See the red LED? That's my hand pressing the button. You can see that the LED is pressing, and you can see it's sending like it should. So, and you can see the red LED, and even on the terminal you can see it says received, and then it says on, right there, off. So you can see on, off, on, off. So, all right, that's it for this demo. All right, guys, so let's talk about some use cases. We'll start with the first case, which is security system. So you can connect a distance sensor to or PIR to the Pico W. And then of course you can ring an alarm by connecting to a speaker. So you can alert the presence of intruder and send information to the Pi via console, or if you have any kind of display you can use that instead. Another example is a weather related project. So in this case, you create a weather vane by connecting a temperature sensor to the Pico, and the Pi will receive the data either through terminal console, an optional display such as an I2C display, such as an SPI display, or maybe DSI display, or display data on an Excel spreadsheet. And of course, you can also combine an anemometer to the weather vane to measure temperature, humidity, and wind speed. And again, you can do the same thing to display data by using the console, spreadsheet, or an optional display. Then we have robot controller. So we use the Pico W as the controller and the Pi as the robot. Then we add a potentiometer to the Pico, and of course we add extra pins on the Pi to add speed control. And of course the buttons will control movement. So here are some other projects you can do. A door opener. Use an accelerometer to detect anomalies. For example, if there's an earthquake. A plant monitor. You connect an air quality sensor so that you can monitor air quality, and even use RGB LED strips such as neopixels with potentiometers to change colors of the LEDs. For example, if you wanted to create a nice Christmas display, and so many more. However, there are some disadvantages of BLE communication. Let's take a look at some. First, we have limited data transfer rates, limited range. Again, this is going to be important if you are going to build a weather vane, for example, so keep that in mind. Device compatibility with legacy Bluetooth. This is only an issue if you're trying to use legacy Bluetooth. Complex development process. This is going to be an issue if you're new to BLE. Security issues, which is very common with Bluetooth, unfortunately, so you'll have to be careful if you are using BLE. And of course, I will link the article in the description so that you may learn more. So, that's it for this video, guys. Thank you so much for watching this entire series. I will be returning to the series every now and then with some projects. So, I'll see you next time. Take care.